Hi, and welcome to our Codelab. This time what we're going to do is to look at the statistics. And this lesson is going to be around the getStats command. So we'll start by understanding what it is and how it works. People care to share a bit of the code there?
Yes. So WebRTC has an API for getting the statistics of a connection, and it's called getStats. And one of the common ways to use it is to call it in an interval, like every second, every 5 seconds. And here we are in our common index HTML file in our create peer connection function.
Okay.
And at the end of that, we set an interval, and in that interval, we query the statistics of the connection.
Okay, and you're running this, in this case, just every 2 seconds.
Every 2 seconds, and when the peer connection is closed, we can remove the interval. So we don't leak it and have something going on every 2 seconds. That doesn't give us any new information.
Okay.
And it's an asynchronous function, and we always store the last result we get from that. And then pass it in again.
Why do we store the last result?
Because we want to compare the current result to the last result and then calculate a difference between certain values, like the number of bytes sent.
Okay. I think before we actually go into the query bitrate stats, I'd like to explain a bit more about the data that we get from getStats. And there are like two separate types of data in my mind when it comes to getStats. There's the things that are ongoing, okay? I'm going to query like we do here with the interval every 2 seconds, 5 seconds, 10 seconds, pick a number. And then check the differences, things like what is the bitrate, what's the jitter in the call, what's the packet loss, and other statistics that change dynamically over time. And then there's a part in getStats that is more static in nature. It's like once we've opened the connection and until something big happens, things will not change there. And we will start by looking at the things that change, the dynamic parts. Okay, that would be the set interval one. And then we will look at the things that are more static in nature. Okay, now in this slide that I'm showing now, what you see is, let's say, the dynamic parts of getStats. When you call getStats, it gives you back a JSON blob or a kind of an object which is linked or connected to other objects that getStats creates. And the main object in our case is RTC transport. That is the peer connection itself in a way. And in that we will have, for example, outbound RTP streams for audio and video. These would be connected to remote inbound RTP streams, okay, which are the statistics that we get through the RTCP channel from the remote side for what we are sending him. So if, for example, I'm sending out data, okay, I would look at the packet loss on the remote inbound stream because I can't know what the packet loss is without the other side telling me the packet loss that he's experiencing, okay? Then we've got the inbound RTCP streams, and these are the streams that are coming into our device, into our peer connection, and they also have the remote outbound RTP streams for them, which is again the RTCP data or statistics that come along with the incoming streams. These are also connected to media streams, media stream tracks, the sources of audio, video, and the codecs that we are using. Some of them are more static than others in the type of parameters that are providing us. And what we'll do now is look at how we've used it in our code, in the Codelab, in order to get the bitrate and understand what's the bitrate that we're sending to the other side. So Fippo, back to you.
Yes. So getStats returns a big map object, and that map object contains statistics object, and you can traverse them, as you said. And we would usually be able to call the peer connection getStats function and find, for example, our video track. But the WebRTC API also offers a bit more specific way to call getStats, and that is what we're using here. So we want the statistics from the videos that we send. We call PC get senders to find our video sender. So we find the sender which has a track and where the track kind is video. And if we have that, we call getStats on the sender, which gives us a limited set of statistics compared to the full peer connection stats.
Mm-hmm.
It's a asynchronous function. It returns a promise, so we use await. And we can do that because our query bitrate stats is an asynchronous function. And then
yes, I think before we continue, that's a very important thing. GetStats has two variations to it. There is the asynchronous one and there is the non-synchronous one, or there's the asynchronous one and the promise-based one. Sorry.
There is the same.
Yes, but there is the new stats and the old stats, and we're using here the new stats.
Yes, there is the Google legacy stats, which are only available if you use the callback version of GetStats.
Yes, that's what I meant.
In new code anymore.
Mm-hmm.
The Google stats were fine and great, but they weren't documented and mostly built for certain Google products, and you can't rely on them, and they're going away shortly.
Mm-hmm.
So then we iterate this stats object. It's a JavaScript map, so we can iterate it. We call for each, and we get a report out of that. And we're only interested in reports with a type outbound RTP because we want to know about the packets that are sent by us, the video packets. Mm-hmm. And what we take is the timestamp, which is our current timestamp. We're interested in the number of bytes sent and also the number of header bytes sent. So RTP has a header and a payload, and the total length of the packet is the header length plus the payload length. And we can make a difference between those. It's not that important for video because the overhead from the header on video is very small because you have very large packets, 1200 bytes and up. Whereas for audio, it is much more important because the header is 12 bytes and the payload is 40 bytes. So that's a significant percentage of overhead. And we also get the packet sent. And then if we have a last result, so we have done that before, we can calculate the difference between the values from the current statistics object and the last statistics object. We know that we can get the corresponding object in the last result because the report ID is constant over the calls. So if you have a report, you can get the corresponding last report by accessing it through the same identifier. And then we calculate the bit rate, which is basically the current bytes sent minus the last byte sent divided by the time difference, which in this case is in milliseconds. And then we multiply it by 8 to convert the bytes to bits. And fortunately, our conversion is so that we get kilobits per second, and it all cancels out with the time.
Yeah, so if I reiterate some of it, we look at the byte sent and header byte sent, and these are accumulative over time. Because of that, whenever we look at it, it will give us everything from the beginning point of time of the session, and we only want, from the last time. So what we do is we look at the timestamps, the differences between the timestamps, the differences between the bytes sent that we've had at the beginning and the end. We divide them, and then we get the per second for that time frame that we're looking at, for the interval that we're running getStats on.
Exactly.
Okay. One more question. There are a lot of things here that are searches and finding and stuff that we go on different trees and go through IDs. Does that take up CPU or burden the machine of doing stupid calculations that are not really needed?
You shouldn't call getStats like 50 times per second, which apparently some people did. So in Chrome, it's limited to about 20 per second. The use case for that was displaying audio levels, which were available in getStats, but it turned out that getStats is internally a very heavy operation because it has to ask all the objects inside the peer connection, all the native objects for their current statistics. So in Chrome, there is a lot of caching of these results. So if you call it too soon again, like after 10 milliseconds, you won't see a change. You will just get the last result again.
And does it
be 0?
Okay. And does it even make sense to run it every 2 seconds, the way we do here?
It might. For example, if you have something like a burst loss, so a lot of packets lost in a short period of time, you will only notice that as a sharp increase in packet loss if you call it with sufficient resolution.
Okay. Okay.
If you're just interested in like showing it to the user, just do it every 10, every 15 seconds. That should be sufficient.
Understood. Okay. So that was the part that we dealt with the ongoing statistics. We can go and find things like jitter and packet loss as well. We can look at the incoming data streams on the audio and not the video. We can play with a lot of things here. Some of it we're going to do in a future exercise in the Codelab. And now we want to move to the other part of what we're going to do with getStats. And this is going to be to look at the peer connection itself and understand what happens there with the ICE candidates. So before we go into the code, I want to show again how does that look in terms of the object structure in getStats. So we have the RTC transport, which is, for me at least, the peer connection itself. We're going to search for an ICE candidate pair. Okay, remember we're running ICE connectivity checks. Each connectivity checks means that there is a pair that we're going to use. One is our local candidate and the other is a remote candidate. If there is a match, it means that we can send or receive media on them. And that would make that the active pair in the connection. So what we're going to do now is we're going to look at the ICE candidate pairs, find the active pair, and from that find the IP of the remote candidate. So we are going to try and find who we're talking to or what's the remote IP address that we're sending our data from and receiving the data from. Philip?
Yes, so we are again in our create peer connection function, and we are waiting for the connection to get established. And for that, we use the connection state change event. And if it goes to connected, we are going to call PC getStats, and then we use a then and call on connection stats. So unlike in the previous example where we had a wait call, we're using the asynchronous, the promise-based version of getStats. And we're going to look at that. And for example, we want to find out the peer's IP. Another use case would be to find out what kind of connection you're on. Are you relayed via a turn server? But that is a bit more difficult to show because we don't use turn servers yet, which is a future lesson.
Okay.
So what we're going to do first is to search for the active candidate pair. And since WebRTC is still a bit work in progress, you need some backward compatibility hacks. So we're iterating the results again, like we have done before. And if we find a report whose type is transport, we can set the active candidate pair to something that's called the selected candidate pair ID on this report. So every member of this report that is named something something ID is a reference to another key in the mapping. And since we want to make our code work in Firefox as well, if we don't have an active candidate pair which they might implement at some point but haven't yet. We're going to iterate the report, and we're going to look at all the candidate pairs. And if the report says this is a selected candidate pair, we set the active candidate pair to the report.
Okay, so in the first one, sorry, we simply looked at the transport type report and then just got the candidate pair that is active based on the ID.
Yes.
And for Firefox, we need to iterate across all of them until they introduce that addition.
Yes. And our code will just work with both ways, the new way and the old way.
Because you'll try the new way. If it doesn't work, it means that it's Firefox, simply because we do this when we're connected and we must have an active candidate.
Exactly.
Okay.
So if we have an active candidate pair and we have the remote candidate ID on it, we can get the remote candidate as the active candidates pair remote candidate ID, and we use that as a key in our results mapping.
So we started by taking the peer connection, finding the ICE candidate pair that is active, and now we're switching to see on that active pair who is the remote candidate that is being used.
Yes.
Okay.
And then we have the stats object here that is describing the remote candidate. And the thing is, the statistics API is still a bit of a mess. So ideally, it should have an address property, because address is a new thing that contains the IP address or the host name. But Chrome doesn't implement that, so we need to go for alternatively remote candidate IP, which is what Chrome implements, but it might put an address there. Or we have the even older .ip address member on the remote candidate object. And we will take whatever is available to us.
Okay, and the same for port and port number.
Yes.
Okay.
Exactly. It used to be port number, got renamed, now it's port, but Firefox still uses port number.
Okay, so we've seen a few things in this lesson of the Codelab. We've worked with getStats, with a new API or the new variation of getStats that is spec compliant. We've used it to create, to set an interval and run it every 2 seconds in our case to find the bitrate. And you can extend that to get whatever else you want from that section in terms of jitter, packet loss, other channels, or whatever. Then we've taken the same approach of using getStats and have used it on the connection once we got connected to find other things that we wanted. In our case, it was a remote IP, but you can do other things with it, like finding that you're connecting through a relay server and not directly. And what we've also seen here, and I think it's the first time in the Codelab, is that there are still differences between how the spec is written and what is implemented in each and every one of the browsers, and how we deal with it or try to deal with it elegantly in each case in a way that in the future it will be easy to clean up the code that is no longer needed. Okay, so thank you for joining our lesson and see you in the next one.